Hey there, grade 9s. Welcome to lesson 2 of chapter 4. In this one, we're talking about linear relationships. So one thing that I want to talk about, when we're talking about linear relationships, okay, or linear relations, we are kind of focusing on one particular thing, okay? And I want to kind of emphasize what exactly we're talking about. We're talking about, as you can see, it says line. Okay? And when we're talking about a line, we're talking about a straight relationship. Okay? So what that means is it's something that is constant. Okay? So it's something that increases regularly. Okay? So for example, if you had a job where you got paid by the hour, every single hour you would make that exact amount of money. So that would be a linear relationship. The amount of money you earn based on how many hours you work would be a linear relationship. The more you work, the more you make, and every single hour it increases by the same amount. Okay, similar to if anyone has been scuba diving. Okay, the further down you go, the more pressure is actually put on you, on your body, and that is a linear relationship. So the amount of weight of the water that comes on you, it basically kind of compresses you as a person to the point where when you get to a certain level, you're more likely to sink than float. So here I have an example, and we're going to put an input-output chart. So I've just numbered these rectangles. The numbers don't necessarily represent anything, except that the higher the number, the more the bigger the perimeter. Okay, so here we have basically our rectangle number, and then over here we will have the perimeter. Okay, and we can represent this by n, and we'll represent this by p. So for our first rectangle, we have a perimeter of 1, 2, 3, 4, 5, 6. Okay, so we have a perimeter of 6. In the second one, we have a perimeter, so in rectangle 2, we have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so some of you might be able to see the pattern that we have going on already. In rectangle 3, it's going to be 10. In rectangle 4, it's going to be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we wanted to put this into a graph, I'm going to slide over a little bit. Okay, so we might have something like this. I'm going to have my x is going to be a little bit shorter than my y because my y goes up a little bit more. So if I was to go 1, 2, 3, 4, so 1, 2, 3, 4, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so I'll just count by 2s just to make it a little bit easier. So if I was to graph these, okay, down here would be my n, over here would be my p. So I've got my rectangle number, and then I've got my perimeter. So when I was at rectangle number 1, I had 6. Okay. When I was at rectangle number 2, my perimeter was 8. Okay. When I was at rectangle 3, my perimeter was 10. And I was at rectangle 4, my perimeter was 12. So one thing that you're going to notice is that we are making this straight line that kind of connects. Okay, so similar to the last lesson that we were talking about, one thing that we're going to notice is when we're having a straight line, we're having what's called a slope. Okay, so our slope is actually giving us information on what our formula might be. Okay, so we're going to see as we move over 1, how high up are we going? We're moving 2 up. So the vertical change is actually going to be what we will use for our numerical coefficient. Okay? Or, well, as we'll see, this is our change in our output. Okay, so we would have 2 times n. Okay? 2 times our input. okay? And then where it intersects on the y-axis, okay? So when x equals 0, where does it intersect? That's going to be our constant. So in this situation, we get plus 4. So it intersects at positive 4, all right? So I hope that kind of makes sense. I'm going to slide back over here, and we're going to move on to another example right here with this one. Okay. So in this question, what we're going to do is we're actually going to graph a relationship. Okay. The relationship that we want to graph in this one goes by the formula. Let's see, how high can you guys go? So y equals 3x, I'll move it up, 3x minus 5, okay? So y equals 3x minus 5. So if we wanted to put that on an input-output chart, which we can, which is totally fine, I'll do that over here. So I might have my input and my output. Okay? So if I'm trying to figure out exactly what everything is going to be, I'm going to say, I'm just going to put 1 in. So when my input equals 1, I'm going to have to go back here. So 3 times 1 is 3, minus 5 is going to give me negative 2. So my output is going to be negative 2. When my input is 2, now I have 3 times 2 is 6, minus 5 is 1. Okay, so I'm noticing already that it's following the pattern. My output is increasing by 3 as my input increases by 1. So let's try 3. So 3 times 3 is 9, minus 5 is 4. Okay, I'll go up to 5. So I've got 4 and 5. If I follow the pattern, my next one is going to be 7 and then 10. All right, so we'll stop there. Now, if I want to graph this, okay, the way that it's going to work out is my input is going to be my x-coordinate, and my output is going to be my y-coordinate. So, as I'm at positive 1 on my y, or on my x, sorry, I'm going to be at negative 2 for my y. Okay? My next one, as I go up to positive 2, I'm going to be at positive 1, so I'm going to be right kind of in the middle. When I go to 3, I'm going to be all the way up to 4. When I go to 4, I'm going to go all the way up to 7. And when I'm at 5, I'm going to go all the way up to 10. So 5 and 10. Okay, so if I took a ruler and I connected all these, it would look something like this. Right? So as I can see, my slope is going up. This intersect should be a little bit lower, should be down here. Okay? Like I was saying before, where my linear line, connects with my y-axis, okay, that becomes my constant. Okay? And the change, so as I'm watching, as it goes over 1, sorry, I'll do a different color to make it match like last time. As I come over 1, how high up does it go? In this case, moves over 1, it goes up 3. Okay, so if we were to have a line going in a different direction, okay, if we were to have a line coming like this, this is what we would call a negative slope. Okay, why? Because for every time that we would move over 1, we would come down, so we would have a negative change in our line. So that means we would have what we would consider a negative numerical coefficient. Okay? So there's lots of different examples that we can actually go over. We'll use some applications in class, similar to what we kind of used last year when we were talking about graphing these relationships. If you have any questions, make sure that you bring them to the Zoom. So we're just talking about how we can actually graph these linear relations. But one thing that you do notice is that they all create straight lines. All right. Let me know if you guys have any questions or concerns. Have a great day. Good luck.